For decades, the diesel pickup segment in America has been defined by one relentless question: who makes the most torque? Ford answered with its 6.7-liter power stroke. Ram countered with the legendary Cummins, and GM quietly built its Duramax into a household name. But in 2026, everything changed. When GM pulled the cover off its all-new 8.3-liter MegaMax Diesel, the torquey war did not escalate. It ended. This engine is not a revision or a refresh. It is a ground-up reinvention of what a heavy-duty diesel can be. According to engineers directly involved in testing, the MegaMax does not simply outperform its rivals. It makes their benchmark numbers completely irrelevant. What you are about to hear is the full story of how General Motors built the diesel engine that finally silenced the horsepower and torque arms race for good. To understand why the MegaMax exists, you have to understand the problem GM saw building inside the industry. While other manufacturers were shrinking displacement and leaning on higher boost pressure to meet emissions targets, GM engineers identified a fundamental weakness in that approach. Modern turbo diesels are powerful, but they are operating dangerously close to their mechanical limits. Smaller blocks running higher boost means thinner metal walls, elevated combustion temperatures, accelerated wear on pistons and bearings, and shorter service lives. Rather than follow that path, GM went back to engineering basics. The solution was bigger displacement, not more pressure. By increasing block size, GM could spread heat load across larger internal surfaces. By oversizing the rotating assembly, the engine avoids violent torque spikes that destroy components over time. By designing the block to run cooler under maximum load, GM gave the MegaMax a thermal advantage no competitor currently matches. One powertrain engineer summarized it simply: Ford and Ram kept turning up the boost. We just built a bigger engine. GM has not released official production numbers yet, but supplier data and insider reporting paint a very clear picture. The 8.3-liter MegaMax is expected to produce over 600 horsepower and up to 1,650 pound-feet of torque. Those numbers do not just beat the Power Stroke or the Cummins. They redefine the segment ceiling. But raw output is only half the story. What separates the MegaMax from every diesel before it is how that torque is delivered. Most heavy-duty diesels produce peak torque in a narrow band around 1,600 revolutions per minute. The MegaMax is engineered for a wide, flat torque curve from 1,200 all the way through 2,600 revolutions per minute. That means sustained pulling power rather than a brief spike. For anyone towing a fifth-wheel RV, a gooseneck trailer, or commercial loads past 30,000 pounds, that distinction matters enormously. GM did not build this engine to impress on paper. They built it to haul continuously under real-world conditions. The engineering secret behind the MegaMax comes down to a low-stress torque strategy. Generating torque with boost pressure is straightforward. Generating torque that does not eventually destroy the engine is a different challenge entirely. The 8.3-liter displacement allows the engine to produce enormous torque naturally, which means GM could reduce reliance on extreme boost pressure. Lower boost means lower exhaust gas temperatures, less heat soak, less turbo strain, and slower wear on pistons and bearings. One diesel technician described the difference this way: a large displacement diesel makes power like a trained athlete lifting with proper form. A small displacement diesel under heavy boost makes power like someone pushing a maximum effort until something gives out. GM also completely re-engineered the cooling architecture. Larger water jackets, high-flow oil passages, an oversized EGR cooler, dual-path intercooling, and 20% more radiator surface area keep the MegaMax at stable temperatures even during extended high-output operation. That is where competing diesels have historically struggled. The internal components are built to a standard normally found in medium-duty commercial trucks. The MegaMax features a forged crankshaft, high silicon pistons, steel cylinder liners, heavy-duty connecting rods, and a main bearing girdle for structural rigidity. Engineers say it performs like a detuned medium-duty block because in many respects that is exactly what it is. The turbo system is equally impressive. GM did not bolt a large single turbocharger onto the 8.3-liter block. Instead, engineers developed what insiders call a dual sequential mega boost system. A smaller turbo handles low RPM response, while a larger turbo manages mid and high-range boost. Both are electronically synchronized through a high-speed vane controller, eliminating lag and flat spots across the entire power band. One test driver described the experience this way: It drives like a big block gas engine that produces diesel torque. The power is immediate. There is no hesitation. It is simply there. The transmission paired to the MegaMax is purpose-built. GM worked with Allison to develop a new 10-speed unit engineered specifically for this engine and designed to handle over 2,000 pound-feet of torque in future tuning cycles. It features a larger torque converter, stronger planetary gear sets, advanced thermal coatings on the clutch packs, and a reinforced case to prevent flex under load. This transmission was not adapted to handle the MegaMax. It was built from the ground up to match it. Reliability experts believe the MegaMax avoids the failure patterns that have affected competing diesels for years. Lower RPM torque reduces internal stress. Reduced boost decreases long-term turbo wear. Heavier internals eliminate flex under load. The oversized cooling system prevents heat cycling that causes component fatigue. And because the engine relies on displacement efficiency rather than extreme combustion temperatures, the emissions system runs cooler, generates less soot, and requires less frequent regeneration. As one engineer put it, the MegaMax does not push its limits. It redraws where those limits are. GM engineered the MegaMax around one mission: tow anything, anywhere, without ever feeling close to the limit. Fleet drivers report no heat fade on steep grades, no downshift panic, no torque spikes, no lag when reaccelerating, and strong stability at highway speeds fully loaded. Expected figures include conventional towing around 25,000 pounds, gooseneck capacity near 40,000 pounds, and a gross combined weight rating past 45,000 pounds. One fleet driver said it plainly: "It pulls like a Class 6 commercial truck and drives like a pickup. Nothing in this segment compares." On emissions, GM used displacement as an advantage. Because the MegaMax avoids extreme combustion temperatures and high boost, NOx formation drops naturally. That means less EGR demand, lower DPF soot buildup, longer intervals between regeneration events, and an emissions system that should outlast those on competing platforms. Engineers believe this may be the first modern heavy-duty diesel where emissions hardware does not become the truck's biggest reliability problem. GM built the MegaMax to a commercial-grade durability standard targeting 500,000 miles before major overhaul. Thick block castings reduce vibration. Low operating RPMs minimize wear. Steel cylinder liners allow rebuilds. Oversized bearings extend service life. Oil capacity exceeding 14 quarts controls temperatures on long hauls. This engine is not competing with the Power Stroke or the Cummins. It is competing with commercial diesel platforms designed to run for decades in fleet service. Torquey numbers alone do not end wars. Engineering philosophies do. Ford and Ram chased output by pushing smaller engines toward their thermal and mechanical limits. GM took the opposite approach: bigger displacement for natural torque, lower stress for long-term reliability, cooler temperatures for consistent performance, commercial-grade construction for half-million-mile durability. The result is an engine that does not simply lead the segment. It makes every competing diesel feel like it belongs to a previous generation. No rival can match this without also going bigger, and that requires an entirely new block architecture that takes years to develop. GM did not just win the torque war. They rewrote the rules so no one else can fight it on the same terms. The war is over.